So you have some circles and you have some rubber bands, and what you are doing for whatever reason, what you're doing is you're arranging them equally, and you're fitting them together with a rubber band. And the question is that what would be the length of this rubber band. So for example, this would be the arrangement when we have two circles, this would be the arrangement when we have three circles, and so we can continue. If we take a look at two circles, well, these are the two center of the two circles. Oh, and also for our convenience, what we'll do is we can say that the diameter of these circles is 1 unit. Just for convenience, you can generalize it for any diameter d, but we've taken 1 unit for our convenience. So the first thing we can do is realize that if we connect the center to the point where it leaves, to the point where the rubber band leaves the circle, so somewhere over here I suppose, this would be a 90-degree because it's a tangent. If you connect the tangent line to the center, it makes a 90-degree. And so this will also be a 90-degree. And if I connect the two circles, this would also be a 90 degrees, simply because the portion of that rubber band that leaves the circle would be parallel to when you connect the two centers, right? The reason why I'm doing this is because I can divide my work into uh, portions where the rubber band is straight and portions where the rubber band is curved. So for the case of n equals 2, if this is 1 unit, then we can see that this would also be 1 and this would also be 1. So in other words, it is 2 plus some curved area. Now if we look at the curved area, of course by the similar logic, these would be 90 degrees, and so this would be 180 degree, and this would also be 180 degree. In other words, this is half of a circle and this is the other half of a circle. So if we combine them both, they would cover one whole circle. The rubber band, the length of the rubber band would be the circumference of one whole circle. So the formula for circumference is 2 pi r. R would be 1 over 2. So the circumference of one circle here would be just pi. So this would be 2 plus pi. Now if we take a look at the case when n is 3, these are the centers, and let me go ahead and connect these centers. And since we have arranged them equally, these would be 60 degree, 60 degree, 60 degree. And I can go ahead and make the same rectangles that this is 90 degree, this is 90, 90, 90. And I can continue this. Since there are 3 points, there will be 3 rectangles like this, each of one length, one length, one length. And here too. And so here we can see that this would be 3 plus some curved area. Now uh, if you start doing this for more circles, you will realize a pattern that what happens is that once you have any n circles, this curved surface area is equally divided. So here there are 3 circles, so this would be 1/3 of a whole circle, 1/3 of a whole circle, 1/3 of a whole circle. That is 120 degrees. Here, since there were 2 circles, it was divided between the 2. In other words, half of a circle, half of a circle, and half of a circle. And of course, this is just me telling you. We will go ahead and prove this. But for the time being, since these are 3 circles, this would be 90, 90. The pair of 90 degrees. And so I will call this the exterior angle and this the interior angle. So the exterior angle E, or let me write EX, is simply 180 minus the interior angle, simply because a whole rotation is 360, and then we have a pair of 90 degrees because we are making rectangles, that would be minus 180, and then we can minus 60 minus the interior angle to give us the exterior angle. So here this is 1/3 of the circumference of a circle, this is the other third, and this is the third. In other words, this also makes a complete circle, and so this will be pi. So generally for any n circles, the length of the rubber band would be 3 plus pi, right? Considering that the diameter is 1 unit. sorry, this should be n plus pi. So if we if if we try to go ahead and try to prove this, the n part is pretty easy to see. If you have any n points, then you can make n rectangles, and each length we have taken to be 1, so it will be 1 plus 1 plus 1 and n times. So that's where the n comes from. Now in order to prove the pi part, we would have to prove that for any n circle, this the portion of the curved surface area is 1 over nth of the circle. So the the formula for the sum of interior angles is 180 and minus 2. Right? So for example, if you have a triangle, the sum is 180. The sum of these angles is 180. If you have any four-sided figure, let's say a square or a rectangle, this would be 360 and so on. So the sum of the interior angles is 180 multiplied with n minus 2. And since these are regular, if we divide this by n, this gives us each interior angle, each interior angle. And we saw that the exterior angle is simply 180 minus the interior angle. So exterior angle will be 180 minus 180 multiplied with n minus 2 divided by n, which would be 180 multiplied with n minus 180 multiplied with n plus 360 divided by n, which is simply equal to 360 over n. In other words, every exterior angle will be 360 over n, right? So it's like being equally divided. And since this is 360 over n and there are n circles, then they combine to make a whole circle. In other words, you would be doing 360 over n plus 360 over n plus 360 over n, and you would continue doing this n times. This would simply equal 360. And 360 basically means a whole circle, and since it's a whole circle, the circumference will be pi. So we have proven that for any n circles, it will be n plus pi. And of course, if you want to generalize it, it will be n times the diameter plus pi times the diameter. And we are done. QED.